Before you can write to or read from an SQLite database, you first have to establish what's called a connection to that database. And this idea of connecting to a database is actually pretty universal for database engines and programming languages. So this is a good abstract concept for you to learn, even if you don't plan to use the SQLite database engine. The reason you have to do this for most database engines and for SQLite as well is because SQLite is acting as an interface between your program, your Python program, and the file system. Now, of course, you can open up a handle to a file and print out or write out text into a file if you want, but that ignores all of the features that a database engine like SQLite gives us. We want to be able to access this data from other programs as well. And all of these programming languages, all of these applications that are going to access or read from or write to this database are going to need some kind of engine in between, and that is the SQLite engine. In order to get that engine access to that file, we have to establish what's called a connection. Connecting to a database file can encompass a lot of different ideas. It's going to ensure that we have the authority, the access to read from or write to that database. It's going to ensure that we have the access to read from or write to that particular place on the file system where the database is stored. So it's going to do a lot of different things for us to make sure that we are good to go as we move forward with accessing the database. Inside of Python, connecting to SQLite is very, very easy to do. All we need to do is call this connection function right here, SQLite3.connect. We pass in the name of a file. In this particular example, there's no file path included, so that file has to be in the same location as this .py file that we are executing it from, and that will return an instance of the connection object that we can then use to execute all of our commands against. When we get into reading data from the database, you'll see how we use this connection object. Lastly, we make sure that we close the connection at the end of our program so that we release any handles, any locks on that file that our program might have introduced. So 3 really important things to note here that this code is doing. 1, it's importing the SQLite library. Of course, we have to import that library. Without that library, we can't utilize any of the functions that SQLite 3 offers for us. We always wrap our connections in a try statement. Notice there's a try except here. The reason for that is there's a lot of things that can go wrong during a connection, and if that happens, we want to make sure that we capture any of those problems, any of those errors, and handle them appropriately. So if the file is not accessible, if something else goes wrong, we don't want to continue trying to read from or write to that database without a solid connection having been made. And then lastly, always, always, always close your connections. The reason for this is because when your program is done executing, you don't want to leave any locks on that file or any outstanding connections to that file that may prevent other programs from accessing that file if they need to. This is less important with SQLite and Python because the Python engine, as it cleans up the SQLite connection, will ensure that it releases any handles, any locks on the file. But with other programming languages, with other database engines, it's a very important concept, and it is a great habit to get into. When you are connecting to a database and you're finished, always close that connection. Why don't we take a quick look at this in action? Here is a very simple Python program. I begin by, of course, importing my SQLite 3 library. Here's my try except block where I establish my connection and store it in the conn object, the connection object. And down here I call a function called execute against that connection object, and I'm just selecting star from company. If you're not familiar with the SQL language, all this says is collect every row that's available inside of the company table. A table is almost like a spreadsheet, so get every row, all of the data that's inside of this table, stored inside of this results object, and then I can iterate through that results object with a simple for statement. I'll print out each result from that, and then when I am done, of course, I will close my connection. To do that, over here in my command line, I will execute this and open the database successfully. Perfect. And you can see that there were 2 rows inside of my database. So there was Paul and there was Alan, one from California, one from Texas, and there's some other data and information there. Don't worry too much about how that data got into the database. That's in another nugget. What's important that I was able to connect to this database and pull that data out. Just as a quick point of reference, notice that the testdb file is here inside of the same folder as my code that I was executing. It's 8 kilobytes because that's where that data is stored. So even though my program is now done executing, even though I've selected that data from the database, it's still there inside of the database file. Now, another really interesting thing or important point about SQLite 3, if I delete this file and thus delete all of my data, when I try to execute this, what do you think will happen? Your instinct might say, well, it's going to generate an error during connection because test.db does not exist, but that is not true. I get an error when I try to execute select from company because there's no such table as company, But when we take a look at our file system, test.db is back with 0 kilobytes. Notice right here, there's my testdb file that I just deleted. So what happened? Well, the SQLite 3 library, during its connection, when it didn't find the file, simply created an empty blank database file that had no data in it at all. So that's a really important thing to know about connecting to databases with SQLite 3. It will successfully connect if the file doesn't exist. It will simply create an empty blank file for you. So that concludes this nugget on connecting to SQLite with the SQLite 3 Python library. I hope this has been informative for you, and I'd like to thank you for viewing.